Welcome to this WiseOwl tutorial on using pandas within Python. So here's what you'll learn during this tutorial. So we'll begin by looking at what pandas actually is and its pros and cons and whether it's for you or not. We'll then go on to look at how you can install the pandas module, and then we'll look at how you can create the basic building blocks, data frames and series. We'll then go on to look at how you can show data frame information or information about your data frames, and then look at how you can read from and write to CSV files, Excel workbooks, and SQL Server tables. And I hope you'll see just how easy this is to do. Then we'll look at indexing data frames to make it easier to get at individual rows, or quicker. And then we'll look at sorting and filtering data frames. We'll look at showing statistics, including grouping, at which point the syntax will get a little more difficult, perhaps a tiny bit. We'll look at how you can create columns using expressions, and we'll look at how you can rename columns, how you can join tables together, and how you can remove duplicates. Just three things which didn't seem to fit in anywhere else. And finally, we'll show a quick introduction to matplotlib, showing how you can create charts based on pandas data frames. At the top right of the screen, a link will appear about now, and you'll be able to click on that at any time to download any files or exercises to do with this tutorial. And you can get to the same link from the YouTube page for this tutorial. But that's enough of me. It's bye-bye. And over to Sven. So let's get started. So let's start with the fundamental question. Why is pandas called pandas? Here's the Wikipedia page for pandas at the time of speaking. And you can see from this that the pandas name is derived from the term panel data, or it's a play on the phrase Python data analysis itself. And the only problem with this theory is neither of those gives anything remotely like pandas. So my theory as to why pandas is called pandas is because everyone wanted to have pictures of nice fluffy pandas all over the place. But anyway. So what is pandas? It's like Excel, and the easiest way to understand it, I think, is in comparison to Excel, which I hope is a concept people are familiar with. So there's an Excel spreadsheet listing out some films, and there's the equivalent pandas data frame, as it's called. So in Excel, you can import data, you can create formulae, you can create charts, and you can create pivot tables or pivot your data, and much more besides, admittedly. And in pandas, you can import data from Excel, CSV, wherever it may be. You can create formulae, far more so than in Excel actually. You can create charts using a separate module called matplotlib, which I'm going to touch on right at the end of this tutorial, but we won't cover in any more detail. And you can pivot your data, although admittedly the results won't be as easy to interpret because you won't have the nice glossy interface of a pivot table. So that's what pandas is. Let's look at the building blocks of it. There's two main ones, data frames and series. So here's a data frame. It consists of a set of rows of films, and it consists of 5 separate series. So I've highlighted there one of the series. A series consists of the data itself in a column, but excluding the column title. So let's look now at why pandas beats Excel, and then we'll look at why Excel beats pandas before we get started. So reasons pandas is better than Excel, it's less limited by the size of the data. Excel is limited to 1 million rows, but not only that, it can run very slowly long before that, whereas because pandas doesn't have any visual interface to maintain, it can run much more quickly behind the scenes. Secondly, it's got far more tools for analysis and for data cleaning. And thirdly, it's free. You don't have to pay a license fee to Microsoft. And of course, it gives you a chance to practice your Python. Against that, here's why Excel might beat pandas. The number one is you can see what you're doing on screen. So the visual interface is much clearer. You don't have to keep showing your data frame again. It's got a much bigger user base, so you're going to find more people who know Excel than have the skills to use pandas. And finally, and most controversially, it's quicker to do things. I realise that this could be construed as a matter of personal preference, but surely if you know Excel and pandas inside out, it's still quicker to use Excel to do most things. I'll leave you to debate that yourselves. But now I think it's time to start using pandas, beginning by installing it. So in order to be able to use pandas, you need to first install it. You can see I haven't got it installed on my machine, and that's why I'm getting the error message. So to do this, you need to go to your terminal window. And what I'm going to do is just prove that I've uninstalled all of the other modules, I think all of the other modules that I installed in making all the other tutorials in this series. So I've almost got a virgin copy of Visual Studio Code. So what I'm going to do is install pandas, and to do that you type pip space install space pandas. And when you press return, it will say what it's installing. And you can see it's installing pandas, but it's also installing NumPy. So NumPy is a package or module which allows you to work with arrays, and it's also installing something called 6, which I must admit I know little or nothing about. But you'll very rarely see the line import pandas, even though it's now going to work. Instead, most people give it an alias and say import pandas as PD. So from now on, you're going to include every single program we create will include that line at the top. And having installed pandas, I think it's time to start using it. So to show creating data frames and series, I've created a file called a-gettingstarted.py. And accompanying this tutorial is a file called example-dataframe.png, which is just a picture of the data frame that we're going to create. So in order to be able to do this, we need to be able to create a dictionary, and the dictionary will have keys and values. So the first key will be the word ID, and that will be used to pick up on the values of all the numbers in the column. The second key will be the title, and the values for that dictionary key will be all the films, and so on. So what we'll do is create that dictionary and use it as a basis for our data frame. Although normally you would import a data frame from another file, which is what we'll do shortly in this tutorial. So to do this, the first thing I need to do is create a new dictionary. I'll call it films, and I'll put a comment in above it to denote what I'm doing. So I'll call it films, and it's a dictionary, so it needs curly brackets like that. What I can then do is specify the first key, which is the ID. And the values for that will be a list of values. I'll make it, and they go 1, 2, 3, 5, 6. For some reason I missed out 4. I'm not quite sure how that happened. And then I could go on to the next key, the title, and so on. Now it's not very interesting watching me doing that, so let's paste that in from the clipboard to get my dictionary. So those are my films. What I can now do is use those to create a data frame. A pandas data frame based upon this. And to do that, I'm going to call my data frame df for data frame. And what I'll do is take the pandas module, which I've given the alias of PD, and I will create a data frame based on that. And the argument I'll pass to it is a dictionary. So it's going to be the films. And what I want to do then is to prove this works. So I'm going to print out two things. The first thing I'll do is print out the type of that, because I want to show you what you've got. And then we'll print out the, the data frame itself. So if I run that program, you'll see I get the type of it. It was a data frame, I'm pleased to see, and the actual data frame itself. So that's one way in which you can create a data frame. I'll just comment those 2 lines of code out so I don't print them out again. And what we'll now do is create a series, so an individual column, which is the other building block, if you remember. I'm going to base my series on this list of films, so I'll just copy that to my clipboard. And what I'll do now is create a list. So I'll call this film titles and set it equal to my list of films. And then I'll create a pandas series based on this. So to do that, I'll create a variable called film series, and I will do pd.series, exactly the same sort of command, and then I can supply any sequence or list-like object, I think it said in auto-completion there, or in the help. So I'll base it on my film titles. And then what I'll do is do the same thing to prove this works. So I'll print out the type of this. And then I'll print out the object itself, or this film series itself. And if I run this to prove this worked, I will get 2 things again. This time I've got a series, which is a subclass or a subset of a data frame, and I've got the actual series itself. So that's how you can create data frames and series, although as I say, you would normally import them from other files, which is what we'll do shortly in this series. So we're going to look now at showing both information about a data frame and parts of it. And to that effect, I've created a file called bshowingdataframeinfo.py. And I've copied in the information from the previous example we did. So I've got a dictionary of films, and I've used that to create a data frame. So the first thing I might want to ask is, show me about my data frame. So you can print out general information about a data frame by printing out the name of the data frame .info. And info is actually a function or a method, so I need to put open and close brackets after it. And if I run that, you'll see I get some general background information, quite useful stuff on my data frame. I can see what it is. I can see how many columns I've got, and I can see for each column what the data type is. I can even see how much memory it takes up, which for large data frames could be very useful. I'm not quite sure what that none is at the bottom. So you could also, let's just comment that line out, be more specific and just get information on data types. And to do this is very similar, but instead of using the info, you just use the data types property. And if I run that, you'll see I get the data types, my 5 columns. So 2 of them it was able to pin down as integers. The other 3 just contain strings or dates or something less specific. So I'll comment that out. You can also get summary statistics. Now, much more on specific statistics later on in this tutorial, but for the moment, it's useful to know that there's something called describe, which is a method and needs brackets. And if you run this, you will get a quick summary of statistics. So you can see for all of the numerical columns in the data frame, it's shown how many there are, the mean, the standard deviation, and all sorts of other interesting statistics like the 25% percentile. That's what you get by default in a template. Obviously, you can fine-tune that and get exactly the statistics you want. So that's how you can show information about a data frame. You can also show information or show part of the data frame. So you can show top and bottom rows, for example. So I might decide I just want to look at the first 3 films. So to do that, I can use a head function, and in brackets, I can specify how many rows I want to get. So if I put 3 in there and then run that program, you can see I just get the top 3 rows. You can also put negative numbers in here, slicing like. So if I put -3, I will get the, going up from the bottom, I will miss out the bottom 3 rows and just get the top 2. But there's no real reason, I think, to use minus signs, because instead of that, you can also use the tail function. So what I could do is show the bottom 3. That would show the last 3 films. So head shows the top rows, tails shows the bottom. One interesting thing about this is if I put in a ridiculous number in there, it doesn't actually crash, it just shows all of the rows. And likewise, if I put in a ridiculously large negative number, so that can't show anything, it just shows an empty list. So it's quite forgiving. So that is how you can do heads and tails. And the last thing I was going to do in this section is to show how you can show specific columns. So the first thing I'll do is just show a single column. So we'll take the data frame and we'll specify which key you want to pick out. And I'll just show the title column. So you're accessing a key in the dictionary, all of which makes perfect sense to me. And I run that, I'll just get a single column. In fact, what I'm doing there is returning a series. So that makes sense. The next bit may be less so. Let's suppose I want to show the ID next to that. So I'll create a list which contains the 2 keys and pass that in as well. So this should show a data frame with 2 columns. If I try running that, it will get an error message. And not just an error message, but a difficult to understand error message. I must admit I can't see anything in there which is telling me what the problem is. The problem is that when you're using this syntax, you need to pass in, you need 1 square bracket to say here's what I'm using. And then if I'm passing in a list, I need to denote it as such. So I need to include 2 square brackets, one after the other at the beginning and the end. And in my experience of using data frames, this is the hardest thing about them. The syntax of what things expect to be passed can be quite unpredictable, And you often find yourself having sequences of brackets. You need to think very carefully about what you're doing to avoid syntax errors. But anyway, if I now run that, you'll see it gives me my 2 columns. So what I want to do now is show how ridiculously easy it is to read and write CSV files within Python. I've hinted at this in previous tutorials saying, don't bother reading CSV files in line by line, just use pandas to import them into a data frame. So we'll start with writing the dictionary I've created out, or the data frame I've created out, to a CSV file. So I've created a new file called creadandwrite csv.py. It contains this data frame containing a variable called df, and I'm just going to write this out to a CSV file. And to do this, I'll just put in a comment. But to do this, I can take my data frame and I can use the dot to CSV. What could be easier? To get the path, I would normally just paste it in, but I thought I'd show you how I've been doing that. You can right-click on the folder in which you want to store it, and you can choose to copy the path. And what I'll do is just paste that in here with a little R and some quotation marks, and then add on the file name. So let's call it films.csv. That is that. It really is. If I now run that program, you can see it creates a file called films.csv. Now there's only one issue with that, which is this rather weird comma. Let's just highlight it there, at the top left, the preceding comma. And the reason that's coming in, I know the solution. I'm not quite sure I understand it, but that's okay. The solution is to add an additional argument saying the index for argument should be set to false. I think it's actually got a little I in there. And if I run that again, you can see it gets rid of the I. I've read up a bit. I still don't understand the reason, but the solution works fine, so that's good enough for me. You could also, if you like, have a play about with some quotation marks. So you could set a quoting variable to specify whether you're going to use quotation marks or not. So there's various values for this. If I use 2, for example, then you can see I get quotation marks around just the text. I think if I'd used 1, I would get quotation marks around everything. And if you don't like those quotation marks, you could go back in and add another argument, the quote character. And I could say I'll use a pipe symbol instead. It's at the bottom left corner of your keyboard if you want to play around with it. If I run this again, you'll see I get different quotation mark characters. So they couldn't have made it easier to create a CSV file. And reading it in is just as easy. So what I'm now going to do is read in the CSV file I've just created into a new data frame. So I'll create a variable called newDF. What I'll do is take the pandas module and apply the read CSV method. I need to know where I'm getting it from. So what I'll do is just copy this from the line above. Then to see if that's worked, I can print out my data frame I've just created. If I run that, you can see it gives me my data frame. Unfortunately, it's included the quotation characters because I haven't specifically said not to. So what I need to do is add an additional argument saying that my quote character is a pipe. And let's see if that's sufficient to do it. It is. That's how you can write and read CSV files. It's so easy. Having looked at CSV files, what we're now going to do is look at how to read and write Excel. So I've created a program file to that effect, which creates my standard data frame listing out the films. And what we'll do, as we did with CSV, is to write it out to an Excel workbook and then read it back in again. Now, in doing this, you'll find that writing and reading Excel files is nearly as easy as CSV files, and you'll realize why I kept giving warning messages about this in previous tutorials. Pandas really does make it easy to load and export data. So we'll start with writing out the data. So to do this, I can write the data to an Excel workbook. And because I know I'm going to need the name of this path, I'll just right-click on the folder and choose Copy Path. And to do this, what I can do is take my data frame called df and I can send it to Excel. And the argument I'll specify is the folder location. So to do that, I'll just put it in quotation marks and I'll call it films.xlss, beg your pardon. And then I'll try running that. And when you run it, I don't think it will work. And the reason is it's saying it's got no module named OpenPyXL. In order to be able to communicate with Excel, it needs some sort of library or module enabling it to do this. And to use the modern version of XLL with, since Excel 2007, I think, XLSX files, you're better off actually ignoring that and using the XLS writer module instead. So what I'm going to do is install that. So if I type pip space install space XLSX writer, and press return, that will install that. And what I can then do is to import that module to the top of my program. And then I can specify that this is the engine I'm using. So when I write it out, that's a module which will help me do so. So I can specify that that's the module I'm using, but that needs to go in quotation marks. So let's try that again. If I run that again, this time you can see it's worked, or at least it hasn't generated an error message. And if you look at my films file, you can see that if I right-click on it and choose Open Preview, then you can see the Excel data. Just a quick reminder of what I just did. Visual Studio Code doesn't have a native way of viewing Excel files. But if you go to your extensions and if you install the Excel Viewer extension, then what you'll be able to do, as I just did there, is to right-click on a file, like the films file, films workbook, and choose Open Preview, and you'll be able to view it within Visual Studio Code. Now, that was really good. Probably just two changes I'd like. One is I don't particularly want this first column giving the row number. It's called the indexing of it. And the second thing is I don't really want it to be called Sheet 1. I could do with a better name. So what we'll do is just tweak this by adding two more arguments. So the first one is, as for CSV, our old friend, the index argument, and I'll set that to be false. And that will stop the row numbers appearing on the left-hand side. And the second argument I can specify is sheet name, and I'll call it list of films. There are many other arguments you can specify to say, for example, which columns you're exporting, etc. But that will do for me. So if I run that again, it seems to have worked. I need to close the Excel workbook down and right-click on it and preview it again to see the latest results. And you can see my worksheet has got a better name and I've lost my row numbers. So that's how you can write to Excel. What we're now going to do is read back from it. So I will just comment out all of that. We'll read in the file. So to do this, I'll create a new variable called new dataframe, or new df, and I'll do exactly what I did with the CSV file. I'll take the pandas module, and instead of using read CSV, I'll use read Excel, and then in brackets, I'll specify my path. Paste that in. Then I should just be able to show the data frame I've just imported. So does it work? I think possibly not. If I try running it, you'll see it's missing the dependency OpenPyXL. So I think XLSX writer is for writing information. I need to read it in, and to do that I need OpenPyXL. So it's back to the terminal window. Pip install OpenPyXL. We used this in a previous tutorial to write information to Excel. If I install that, what I should then be able to do is to import that into my program and try running this again. And the next time I run it, you can see it gives me the information I wanted. I think the reason it's automatically picking up, excuse me, on the correct worksheet is because that's the first and only one in the workbook. If I wanted to be more specific, I could go and add the sheet name, and say it's called list of films. So I could choose which worksheet I was going to import. And if I run that one more time, you'll see it gives me exactly the same information, which looks to me to prove it worked. So that's how you can read from and write to Excel workbooks. Finally, in this mini-series, let's have a look at how you can read from and write to SQL Server tables. What we're going to do now is to read and write to and from SQL Server. And after the euphoria of working with Excel and CSV files, this is going to be a bit disappointing, I'm afraid. I've created a file called e-read-SQL-server.py, which contains our usual data frame. And what you're probably expecting me to say is that you can use the to_SQL method to write to a SQL Server database, and you can. But if you go to the Pandas page on it, what you'll see is it says that databases supported by SQL Alchemy are supported. And that means anything else isn't. So you can use that, but you'll need to create something called a SQL Alchemy engine first. And while that's a perfectly feasible way of proceeding, I think on balance it's easier to use it to proceed without that, and so not use this method at all. So what we're going to do is just write the rows out one by one from a data frame as follows. I've created a SQL Server table called TBL film, which contains all the necessary columns, and one more as well, actually. The one more is the film ID, which will be used to number each one sequentially. And what I'm going to do is go back to that and run it, and hopefully you'll see that the films in my data frame have appeared in it. That's the aim. So going back to my module, the first thing I need to do is create a connection to the database. Do that. I've actually got that in my clipboard. What you do is create a variable called cn and connect to the database using the PyODBC module, except I haven't got a PyODBC module, so what I need to do is install that. And unfortunately, I haven't even installed it, so I'm going to have to go to the terminal window and type pip.install PyODBC. At this point, if you watch my previous tutorial on writing records to SQL Server and reading them back in, you may be getting a sense of déjà vu. The whole process is very similar, I'm afraid. So now I've got a connection to my database. What I can do is create a cursor. And to do that, I'll actually explain what a cursor is quite. I'll create a variable called CSR. And from my connection, the cursor. A cursor is just something which allows you to either display records from a database or execute commands against it. Before I continue, I'm going to do one more thing. You possibly can have spaces in column names in data frames when you're writing to the SQL Server, but I can't work out how to do it. Having Googled it for some time, I'm just going to make my life easier by removing the spaces. So that's cheating ever so slightly, I will admit, but anything for an easy life. So what I'm now going to do is to loop over my rows of the data frame. And to do this, I can say for. This is like an enumeration. There's two columns returned. One is the index number of each row, which I've no interest in at all, but I need to capture in a variable. And the second one is the actual row itself. So I can say for that in the dataframe.iterrows, and I use open and close brackets after that, and that will allow me to loop over the rows in my data frame. And for each one, what I need to do insert this row into my database table. So I can do this by saying csr.execute. And what I'm going to do is build up a long SQL statement. So insert into. The table was called TBL film. The fields I happily gave exactly the same names as they were called in the data frame. And I didn't have to, I could have called them different names, but I did to make life easier. And then I need to say what I'm inserting into them, which is 5 question marks. And what I now need to do is to say one by one what I'm going to put for each of those question marks. And that's what this star params is. You can now specify all the parameters to go into this. So the first thing I'll specify is the ID. So row gives me access to the row and ID gives me access to that field. There's no IntelliSense appearing, it's up to me to remember that. So I can put in the title, and obviously these have to be in the same order as I specify them in the insert statement. Row.runtime and row.genre. So that row should execute 5 insert statements, and the last thing I need to do is commit these changes. basically write them back to the database. If I don't do that, I won't be able to see the rows in the result. And I can do that by typing cn.commit. Very easy to miss out that single statement. And finally, I'll close down my connection. The cn.close. So it's not much easier than it is not using a data frame, I'm afraid. So, will it work? Actually, the answer to that question I've just realized is probably not, because I missed out the word values in there. All you SQL programmers, did you spot that deliberate mistake? So now let's ask, will that work if I try running it? Well, no error messages, that's a good sign. And if I go into SQL Server Management Studio and try executing this, you can see I've got my 5 rows in. So that's how you can write to a SQL Server table. What I'm happy to say is the process of reading in information from a table is much easier. So what we're going to do is read the list of films into a data frame. I'll comment all this out in a second, but I'll just borrow that little command to create the connection if I may, and then comment the rest of it out. But I'll keep in the 2 modules I'm going to need, Pandas and PyODBC. So now what we're going to do is to read information in. And to do that, the first thing I'll do is create a connection to my database. I still need that. I don't need a cursor, but I do need a query. And the query will say which records I'm returning. So I'll create a variable, let's call this SQL query. And what I'll do is select all of the rows and all of the columns from my TBL film table. And let's order them by the title, just to prove you can amend your SQL statement from the standard. So having done that, all I now need to do is read in the data. And to do this, I can create a new data frame. Let's call it film data frame. Data frame there, the film data frame. And I will take the Panda module. I will apply the read SQL function. The first thing it's asking me for is what my query is. It's SQL query. And the second thing I'd want to know is what my connection is, and that's CN. I did say it was easier. And then having done that, I need to close down my connection. So I can put cn.close. And finally, let's check it works. To do that, I can print out my film data frame, and let's see if it worked. So if I try running that, you can see it gives me my data frame. So writing information out is a pain, but reading it in, which is probably what most people will be interested in doing, is much easier. So what we're going to do now is look at 2 ways to get subsets of a data frame out. One is using slicing and the other is using indexing. The first one uses something called iloc and the second one uses loc. I've created a file called fslicingandindexing.py, and it contains my usual code to create a data frame. And if I print that out just for old time's sake, for nostalgia, you'll see it gives me a list of my 5 films. Supposing that I just want to show the first 3 films, and I want to miss out the first column here, the ID column. How would I do that? Well, I could use slicing. And at this point, if you haven't already watched tutorial 7b, I think it is, on slicing, what I'd suggest is going back and watching that, because it's such an important topic in Python. So what I'm going to do is create a variable called subframe, and I will set it to be the original data frame. What you're probably expecting me to say now is to type in a square bracket and specify which rows and which columns I want it to pick out. And that's how it worked for NumPy, for arrays. But if you're using data frames, you need to put the iloc qualifier in, I guess, and then it will work exactly the way you probably expect it to. So I said I wanted the first 3 rows. So to do that, I could put :3. What that will mean is begin at the beginning and keep going up to, but not including the row number 4. Don't forget rows are numbered from 0 to begin with, just to keep you on your toes. And for the columns, I said I wanted to miss out the first column, so I'll start at the second one and keep going to the end. So if I now try printing that out, you'll see I hopefully get the information I wanted. So I've missed out the first column and I've only got the first 3 rows. And you can do everything you would expect. So for example, if I want alternate rows, just do one more example. I could create another variable, let's call it alt rows. And I could take the data frame and use the iloc qualifier. Still not sure if that's the right word. So looking at the rows first, I could say take all the rows beginning at the beginning, ending at the end, but take every other row. And just for fun, I could begin at the beginning and end at the end of the columns, but take every other column. If I then were to print that out, you would see I would get every other row and also every other column as well. So that's why I'm getting that there. So slicing works exactly the same. The only thing I need to tell you is to put the .iloc in, otherwise it won't work. Indexing. So what I'm going to do now is to comment this out, but just before I do that, I think I will need those lines of code in a second. And we'll have a look at the topic of indexing, which actually looks very similar. So I've created my data frame there, but what I'm going to do, so I've created a dictionary and created my data frame. What I'm going to do is add an additional argument. I'm going to specify my indexes. And what the indexes do is for each row, they assign a unique value. If you used Access or SQL Server, you can think of it as a primary key. I just need to make sure they're unique. So I'll create a list of indexes. And they really don't have to be in sequential order. I don't think they even have to be numbers, although they usually are. So let's go for 17, 13, 22, 8, and 49, which are as random numbers as I could think of the top of my head. What I could then do is decide to print out only certain rows. To do this, I could create a variable, let's call it certain films, and set it equal to the original data frame. And instead of using iloc, I could use loc. I guess it stands for locator. I could put a square bracket in, and then in another square bracket, I could specify the index numbers I want to list out. I need to be careful I specify ones which actually exist. So let's have 22 first, and then we'll have 49, and then we'll have 17. So just 3 rows. If I then run that, or rather print that out and then run it, so I'll display my certain films. And if I run that, you'll see it just gives me the 3 rows I requested: King Kong, Titanic, and Jurassic Park, which I presume are the correct order. King Kong was the 3rd, the 5th, and the 1st. So it looks about right. 3rd, 5th, 1st. The benefit of using indexing like this is that if you index a data frame, it's very much quicker to access rows by their index number. So with 5 rows, it's going to make no difference whatsoever. But if you've got 5 million rows, you'll find indexing hugely speeds up retrieving data. So the only difference is you use loc instead of iloc. So sorting and filtering are another thing with data frames, which are surprisingly easy, particularly if you sat through the NumPy tutorial. I've created my usual data frame in a file called gsort and filter, and what I'm going to do, unsurprisingly, is sort it and then filter it. So let's start with sorting it. So we'll sort it by the genre and then by title. So I'd expect to see all the action films appearing first, but they'll be subsorted by the title, then the adventure films subsorted by the title, and then finally the romance film. That's if it works. So what I'm going to do is create a new variable to hold the sorted data frame. And to do this, I will take the data frame and I will apply the sort values function, I guess. And within this, I need to specify a list of sorted values. So I'm going to use named arguments to make it easier to read. So my first argument will be a list of all my sort keys. So the first one is the genre, and the second one will be the title. And then I'll specify another argument, even though it's optional, I think, which is whether I'm going to do this in ascending order. I strongly suspect the default is true anyway, but I'm going to reinforce that by actually hard coding it as true. So then if I print out my sorted data frame, you should see it gives me the same information, but in a different order. So I get my 2 action films first, but they're sorted alphabetically by title. Then my 2 adventure films sorted alphabetically by title, and then my romance film. So sorting is pretty straightforward. And filtering isn't much harder either. So what I'll now do is filter this to show all films lasting more than 130 minutes. So to do this, I will create another variable called filter_df, and that will take, let's work with the sorted information to make it easier to read perhaps. And the way you do this is you put a square brackets in. And the idea behind this is I'm going to put inside the square brackets an array, if you like, of true, false values. So I'm going to put in a criteria for a column, which will either be true or false for every single row. And what they do is use that to pick out which rows to display or which rows to include in this data frame. So to do this, I can refer to my original data frame sorted df, and it's the runtime column I'm interested in, but that needs to go in quotation marks. And what I want to do is say where that is got to be greater than 130. May seem slightly surprising syntax. Again, if you've seen the NumPy tutorial, it will be familiar from that. So now if I print out my filtered df data frame, what you'll see is I see only 3 rows in it. It's just there. I could have done with a separator. And those are the 3 where the runtime is more than 130 minutes. Now, there's a lot of fancy things you can do with this. Let's just show you one more example. So let's filter to show all films lasting, let's say 121 or 194 minutes. A rather strange request to ask, but it does give me the opportunity to show one more thing. So I'll create another variable called filtered df2, and I'll set that to take my sorted data frame. I will use again the column called runtime. This time I'll put a dot after it, and I'll say where the value of that is. You can see some of the enormous range of functionality available to you. I'm going to say is in, and I'm going to specify the list of arguments it should be in. And this is one of many occasions where it's easy to get it wrong. So the great temptation is to type in my 2 numbers, which are 121 and 194, like that. But if I go back and have a look at what it was expecting, it asked me for a list of iterable values. So I need to include that in either brackets, round or square brackets to make it a sequence. Otherwise, it won't interpret it correctly, and it will say it's got the wrong number of positional arguments. So what I can finally do is print that out. And this time you will see I get 2 rows, and I'll just hide that to make it easier to read. Except I think I might need part of it, so I'll just hide that bit. And just for the sake of easier reading, let's type in a carriage return. And if I run that, you can see it gives me just the 2 rows I wanted, the 2 lasting 121 and 194. So that's how you can filter a data frame. What we're going to do now is the all-important topic of statistics and grouping based to get information from a data frame. So we're going to look at 5 things in ascending order of complication. We're going to begin with just displaying single statistics, like the average runtime, for example. We'll look at displaying multiple column statistics based on more than one column at the same time. Then we'll look at diverse statistics, I've called it. So you might display the sum of one column but the mean of another. Then we'll look at grouped statistics, so for example, showing the average runtime by genre. And then we'll look at the ag function, which allows you to show different statistics grouped by genre. I think probably a word of warning is in order. If you're a SQL programmer, I think you'll find this harder than you expect to do. It's not that the concepts are difficult, it's just the syntax can be quite finicky, particularly towards the end of this list. But see what you think. So to demonstrate statistics and grouping, I've created a file called h-statisticsandgrouping.py, and it contains our usual data frame, which you're probably absolutely sick of by now. But never mind, it's good for illustrating things. So what I'm going to do is just print that out to begin with, just to demonstrate it's what you think it would look like. And then what we're going to do is work out the average runtime. So to do this, I will create a bit of a comment. So this is a single column statistic. And I'll create a variable called average runtime and set it equal to the following. So I'm going to take my data frame, I'm going to pick out just the runtime column, and I'm going to apply one of many statistics available to me. I'll pick up the mean, but you can see there's lots of other things I could have chosen. And then I'll just print that out to prove it worked. And when I run that, you can see the mean runtime is 156.4. It sounds plausible. So the second thing we'll do is we'll do more than one column statistics. This time what I'm going to do is show the number of unique values in the title column and the genre column. The title column should show 5 because there's 5 unique values, but the genre column should just show 3. And to do this, I'll use another function called nUnique. So I'll create a variable called multcolstats, and I'll set it equal. I'll take the data frame, and what I want to do is pick out the stats for not all the columns, but just 2 of them. So to do that, I need to put another square bracket to create a list of the columns which I want to pick out, and they're going to be the title column and also the genre column. Then I can put a dot in and put nUnique. And I need open and close brackets because that's a function. And I'll print out what I've just derived, the multiple column statistics, and see what happens. I think we could probably do with a little before that. So if I run that, you can see it gives me my statistics. There are 5 unique titles, there are 3 unique genres, and then it's kindly told me the data type as well. If that looks vaguely familiar, that shouldn't be a surprise to you. If we print out the type of it, you can see it's actually returned the data as a data frame series. So that's why it looks familiar. So the next thing we're going to do is the third part. To do for this is to count up how many genres there are and how many unique genres there are too. But then for the runtime, we'll show the minimum, the maximum, and maybe the number of unique runtimes as well. So we're displaying 2 statistics for the genre column and 3 statistics for the runtime column. So to do this, I will create a variable simply called stats, I think, the data frame, and I'll use the ag function. And this is where I think the syntax is going to start getting more complicated. What we're going to do is pass to the ag function a dictionary. So I'll put an open curly bracket in to show that I'm opening up a dictionary. The key to the dictionary is the name of the field. So the first key will be the genre field, and the values will be a list of all the statistics I want to show. And they are displayed in quotation marks. I don't like this. As a seasoned programmer, this is not what's called strongly typed. It's so easy to mistype the information and type in a function which doesn't actually exist. So my next set of statistics after the genre will apply to the runtime. And for that one, I will display the min, max, like I said, the number of unique values as well. Different set of statistics. So getting all that right is not terribly easy. And I think at the very least it deserves an extra comment, which is to display different stats. If I now try printing that out, hopefully you can see I get my answer I wanted. And there it is. And you can see it's actually displaying it as a data frame. Now you may have wondered what it would show for the count for the runtime and for the min and max for the genre. And the answer is NaN, not a number. So make sure that it has a 2-dimensional data type by just putting a blank in for the values where there isn't anything it could display. So we've reached the 4th of 5 parts of what I was going to show you, which is to show statistics grouped by a particular one or more columns. What I want to do in this is show the average runtime by genre. So I'll show the average runtime for action films, adventure films, and romance films. So to do this, I'm just going to firstly comment out some lines of code, just to make it easier to read, and also add in a cheeky little line return so I can make it easier. So we're going to show the average runtime by genre. And to do this, I'll create a variable to hold my final figures. So let's call it average runtime by, why not? And I'll take my data frame. And the first thing we'll do is we'll pick out the columns I want. And because there's 2 columns, I need to put a second square bracket so I can build up a list of them. And they are the genre and the runtime. What I'm then going to do to that is to group it. And to do that, I can use the group by method, and I can say that I'm grouping it by genre. Now, one thing to watch out for is I couldn't actually print that out. I have to carry on and do my statistics at the same time. And what I'm going to do is show the mean. And if you're wondering what it will take the mean of, the answer is anything it's not grouping by. So in this case, I've included two columns, the genre and the runtime. I'm grouping it by the genre, so it will show the mean of the runtime. Okay, so let's see if that works. If I now print out what I've just created and try running that, you'll see it gives me the actions. The average runtime is 137.5, and so on for the other two genres. It's time now to show the pièce de résistance, which is the different statistics grouped by genre. So I'll just comment out those previous lines, and let's go for it. So this time I want to show not just the mean of the runtime, but I'm also going to show the min and the max as well at the same time. So most of this will be very similar. I will create a final variable called final stats, and I will set it to be the following. I will take my data frame, and I'm going to specify that I want the genre and the runtime columns. We'll group them by the genre, so far so similar. And for both of these, you can specify more than one column, more than two columns here, and more than one column you're grouping by. I'm just doing a simple example. What I then want to do is not just display the mean, but build up a dictionary of all the statistics to be displayed. And to do that, as before, I can use the ag function, and I can pass in the dictionary of all the statistics which I want to display. I hope you still got your brackets in the right place. So the first thing I'm going to do is specify, in fact the only thing, is that it's the runtime column I'm displaying statistics for, so that's a key. And the values for this are a list of all the functions I want to display. So they are the min, let's have the mean as well. What I should be able to do is print out the final statistics, and with a bit of luck, I'll see the information I wanted. So you can see you've got the three statistics, the min, the max, and the mean for the runtime. So good luck with remembering the syntax for that. I must admit I struggle with it, trying to remember it. That's how you can display statistics for data frames. What we're going to do now is to look at how you can do column manipulation and column operations. I've created a file called i-columnoperations.py to that effect, and we've got our familiar data frame, and there's just one difference. I'm also printing out the data types of all the columns. So if I run that, you'll see it gives me the output of the data frame itself and their data types. And what I'd like you to notice and remember is that only the first and the fourth columns are integers. All of the others are stored as objects, and that's going to give us a few problems, which I'll show you how to get round. We're going to create 5 new columns. So the first column will take the titles, and for each title it will work out how many characters there are in the title, so using the len function. For the second column, we'll take the runtime and we'll divide it into 2 parts, the whole number of hours and then the whole number of minutes. So for example, Jurassic Park, the first film, will be 2 hours and then 6 minutes. And for the third part, we'll take the release date, which remember is stored as an object, we'll turn it into a date, and then we'll pick out the corresponding year. So that's my plan. In doing this, I think you'll notice 2 things. One is that everything works in a slightly different way. And secondly, you'll realize just how much Pandas is actually based on NumPy underneath it. So it's possible I was slightly disingenuous when I told you in the previous tutorial you don't need to know anything about NumPy to use Pandas, but judge for yourself. So the first thing we'll do is we'll create the new column to hold the length of the title. And this, at least the creating new column bit, is amazingly easy to do. Because columns are stored as dictionaries, all I need to do is create a new key within the dictionary with the name I want to give it. So I'll call it title length. So that part is really easy. What I now need to do is pick up on the field called title. And what I'd like to do is apply the len function to that. But you can see it's not particularly happy about that. Let's try it anyway. Maybe it's got its IntelliSense wrong. And if I try running that, you'll see the object, i.e. the title column, has got no attribute length. It wasn't a string, it was an object. So what I need to do is convince Pandas that this is actually a string of text. And I can do that by converting it to a string. So this is a typical sort of little tweak, which you may find quite hard to work out how to do. So now if I try running that, it will actually work, and I get my title length column at the end. So Jurassic Park has got 13 letters in. So for the second thing we'll do, we'll pick out the hours and minutes in that order. So the first thing I'll do is create a new column called hours. And what I'll do is set that to use the floor function. But I can't use any standard Python functions because I'm working on a cell-by-cell basis with NumPy. So I want to use the NumPy floor function. And to do that, I'm going to have to import it. Now, there's no need to worry about whether I've got the NumPy module installed, because if you've installed Pandas, you've also installed NumPy as well. It's impossible to have one without the other. So that's bound to be there, I would say. So I can put np.floor. And what this function will do is take a number and return the highest integer greater than, less than or equal to it. So what I want to do is take the runtime, which needs to have a square brackets in there, the runtime, and then divide that symbol by 60. And that should give me a number. Well, it should give me a number, but actually what it gives me is a floating point number. Not actually convinced it tells you that there. Maybe it says it in the return statement. There we are. Returns a scalar. It still doesn't actually tell you exactly what it returns, but I can assure you it's not going to be treated as an integer. So what we need to do at the end of that is to convert the type to an integer so we can display it as a whole number. And if I try running that, you should see it gives me the hours at the end. I just need to get the minutes now. So to get the minutes, I'll create another column alongside the original one called minutes. This is going to be much easier. So all I need to do is take the runtime column and use the % symbol, which does work in NumPy, to take the remainder when you divide that by 60. Because the runtime is an integer, this will give me an integer as a result. It should all work. And if I run that, you can see I've got my hours on my minutes. So the final thing I said we'd do now is the dates. So what I need to do is convert the date, I'll put it in quotation marks because it's not, it's an object at the moment, to a real date. Now obviously this will only work if they really are dates. So they've got to be something which Python can actually understand as dates. Otherwise you'd need to cleanse your data before you do this. So we'll create a new column called rel date. And what I'll do is set that to be. I'll take the panda module, and there is a toDateTime function, which, assuming your column is recognizable as a date time, will convert it to such. It was called released, wasn't it? It was called release date. How could I forget that? So what that should do is convert it to a date time. Let's try running that. So it looks the same, but if you look at the data types across the bottom, it's now stored as a date time. And that's important because it means we can get date time type information from it. For example, we can get the year. So a variable called release year, and I will set that to be. There's another date time function. The date time index function will get the date for any particular column or any particular date. So it gets the actual underlying number, if you like. So I'm going to take the release date, which I now know is a date, and having got that as a recognizable date value, I can then, for example, get its year. And if I run that final program, you can see it gives me their release year as well. It was a bit disconcerting when I typed .year, it didn't autocomplete, but it has actually worked. So that's an idea of how you can do column operations and some of the issues you're going to encounter when you do so. It's an awful lot easier if you can do your column operations before you import the data into your data frame, I think anyway. Penultimate part of this tutorial, I want to cover some of the other things you can do in Pandas which didn't seem to slot in to any other categories. And there's three of them to cover. One is renaming columns. The second one is joining data frames together, so that's like a SQL join statement. And the third thing is removing duplicates from a table. We'll start with renaming columns. I've got here a file called jotheroperations.py with some very familiar code in, and if I run that, you'll see it gives me my data frame. But I want to rename the columns. I want to call the release date column just released, and I want to call the runtime column just minutes. So to do this, what I'm going to do is take my data frame and rename its columns. Make a slight mistake in this, so if you know how to do this already, don't worry, I will correct it. So to do this, I can take the df, my data frame, and apply the rename method to it. And at this point, you think, well, surely it's going to come up with something telling me what new column names I need to use. But actually, it's a bit more complicated than that. What I need to do is say it's the columns I'm renaming, and then I need to provide a dictionary for the columns. And the dictionary, the key to the dictionary should be the old name, and the value should be the new name. So I said I wanted to rename the release date, and I do. So let's call that released. And I also said at the same time I wanted to rename the runtime. So let's rename that, and let's call that minutes. Okay. I think that should all work. If I try running that and print out my data frame, you can see it's had no effect whatsoever. And the reason is, if you think about it, this couldn't possibly work. Because when you set up the keys to the dictionary, they have to be unique and are checked at the beginning. You can't just change the value of those keys. It would be chaotic. So instead, what you need to do is create a new variable, let's call it new df, to hold this original data frame with the renamed columns in. And if I print out the new data frame, you'll see it will actually give me the new columns as requested, released in minutes. So that's how you rename columns. So what I want to do now is to show how you can join two tables together or two data frames together in Pandas. And to do that, or to that effect, I've created a file called jotheroperations2.py, and I've imported the Pandas module as a start, at the beginning. And the example we're going to use is this file, which is part of the standard files provided with the tutorial. So it's an Excel workbook containing 2 worksheets. There's a list of 10 films, not all of them actually genuine, but the principle's there. And for each film, you've got the corresponding director ID, who made it. And then you've got a separate worksheet of directors, giving the names of the directors. And what we want to do is tie those two together to show not just the film names, but also the name of the director who made each film. So in database terms, using an example taken from a diagram taken from Power BI as it happens, what I want to do is, given those two tables, I want to effectively create something called a join between them. In most applications, you can do that by dragging the field from one table to the other. But what we're going to do is do that within Python. So that's the plan. So to do this, the first thing I need to do is import my 2 tables. So I'm going to create 2 data frames. So the first one I'll call films. And what it will do is take the Pandas module and apply the read Excel function. The list of the file I'm importing is this one, films and directors. So I'll just right click on that to get the path to it and paste it in here with a little R in front of it. And then I need to provide a second argument, which is the name of the worksheet I'm importing, which is films. And then I'll just copy and paste that to do exactly the same thing to get the directors. I'll call that directors. And as you'll know by now, I'm a great believer in testing things out as I'm going along. So I'll just quickly print out those 2 data frames just to check this is working. And you can see it's all good. So what I'm now going to do is combine these together or join them. To do that, what I can do is create a new data frame, which I'll call combined. And I will take the Pandas module and apply the merge method. And it will ask me for various bits of information. So the left one I'll actually start with the directors, I think. And no, I won't. I'll start with the films. Can't decide. And for the right table, I'll take the directors. Now, in addition to that, I need to provide a few other bits of information. I need to say what type of join I'm creating. So to do that, I can put how equals, and I'm going to say it's an inner join. Now, I don't want to get too much into the theory of joins, although I will do an example of an outer join in a second. But what an inner join means, it will only show me records from the 2 different tables where they match up by the director ID. So I won't see any films which don't have the corresponding director in the directors table, and I won't see any directors who haven't got any films in the films table corresponding. So now I need to say which field I'm joining by. So it may be obvious to you looking through this that we're joining it by the director ID field, but we need to actually spell that out to Python. So what that's doing is saying the left-hand field, the films table, is using the director ID, and by an astonishing coincidence, the field has the same name in the right table, only I've missed out the right on as the name of that argument. So with a bit of luck, that will combine the two tables together. Let's see if it's worked. So let's print out that information. And if I run that program, you can see it gives me the combined information. It looks like it's not working, but that's because I've got too many columns to display on the screen. You can see that it's displaying ... for the missing columns. The only question is, where have all my films gone? I had 10 films. I've only got 8 now. I'm missing 2. I'm missing number 5 and number 10. If I go back to my original data and have a look at what those are, I'm missing of mice and vermin, and I'm missing flying on empty. I mean, they sound a bit dodgy anyway, and the reason I'm missing them is that they both have director number 5. And if you go to the directors table, there is no director number 5, and so it's missing out from the inner join. Now, if this was upsetting me, I could go back and change the nature of my join, and I can make it an outer join. And what that means in this context is I will always get all the films, and if they have any corresponding directors, I'll get their names too. So if I run that program, you can see I get all 10 rows. And for the director name against the 2 extra films, I get NaN, or not a number. It actually means not a value. I also get Paul Greengrass, because he's a director who's made no films, at least in our database. So for SQL programmers, this corresponds to actually a full outer join. That's how you can merge 2 tables in Python. So the last bit of the section I wanted to look at was removing duplicate records, and Pandas supports this in a really nice way, I think. I've created a third file called jotheroperations3.py, and I've gone back to my usual data frame. And if I run that program, which will print it out, you can see it gives me the usual information. So what I want to do is I want to strip out any duplicate genres, keeping the last film in the list. So I'll keep King Kong, but I'll discard Jurassic Park because they're both adventure films, and I'll keep Superman Returns but discard Spider-Man because they're both action films, and I'll keep Titanic because there's no duplicate by the genre column. This is the sort of thing which is hard to do in almost any package, but Pandas makes it very easy. So to do this, I'll just type in remove duplicates. So to do this, what I'll do is create a new variable. I'll call it new df. And what I can do is take the existing data frame and drop duplicates. There's all sorts of arguments you can specify to this, but the main ones are which are the subset of the columns you want to duplicate by or treat as duplicates, and which records you want to keep. So I'm just doing an example. I will say the subset of the columns that I want to use to determine whether something's a duplicate or not is just a genre. So that's not a very demanding constraint. It means any record with a duplicate genre will be treated as a duplicate. Normally you would have a whole set of columns in here, so you'd be more fussy about what constituted a duplicate record or duplicate row. And the other argument I'm going to specify is which one I want to keep. And what I'll do is keep the last. There's all sorts of values you can specify for that, but it's pretty obvious what last will do. So now if I want to print out the results of that, and let's see if it's worked. So when I run that, I should just get 3 rows, and indeed I do. They're there. And you can see it's kept King Kong and Superman Returns as I was hoping. So what I want to do now is to give an overview only of what matplotlib is and does. It's a charting package. So I've got a file called k-matplotlib.py, and what it does is creates and prints out our standard data frame. And what I'd like to be able to do is to chart this by showing the runtime minutes against the film name. So to do that, I'm going to have to import a charting package. So if I put import matplotlib, it always puzzles me how it can recognize modules when they haven't yet been imported. So obviously the next thing I now need to do is to import that. And to do that, I can create a new terminal window and I can type pip install matplotlib. And when I press return, it will install it, along with quite a few other packages. You'll see it's also installing Pillows, Cycler, PyParsing, and Kiwi Solver, whatever they may be. And it would have installed NumPy too, except for the fact I've already got it installed on my computer. So that's good. I can now use that. But actually, the only bit of it I'm going to use is pyplot, and I'll call that PLT. So now that I've imported matplotlib, I can create a chart. And to do that, I'll just get rid of my print statement. What I'll do now is to plot the runtime minutes against the fill name, although I won't succeed in doing that in the first pass. It'll take 2 passes. So to do this, I can create or refer to my PLT submodule, if you like. And what I can do is plot out the data frame. But I don't want the whole data frame because it contains text information. I need to pick out numerical information. So what I'm going to do is pick out the runtime minutes. And if I run that, I'll just need to show that as well, otherwise you won't actually see anything on screen. And then if I run that program, you should see it pops up with a nice line chart of the data. The x-axis is just showing 0, 1, 2, 3, and 4 because I haven't given it any additional information. So I'll just tweak this in one way, and that's to add in an index to my data frame. And what it will do is use the index instead as the plot labels. So to add in an index, I can just put a comma in there, and I can say index equals. And we covered this earlier in the tutorial. It's just a way of making it quicker to access data. What I'm going to do is use my fill names for my index. So I'll just paste those in, get rid of a little space there. And if I run this a second time, you can see that it will give me better labels, so it's much easier to read the chart. Now, there's a lot you can do with matplotlib. And maybe in a future life, I'll generate a whole series of tutorials on the product. But to be honest, I probably wouldn't hold your breath because it's fairly easy to learn. It's just a bit tedious working out what all the options are. What I have done is included a file called usefullinks.txt, and this contains a link to the main matplotlib tutorial, which is excellent and comprehensive. So happy browsing in that, and you should be able to find anything there. And with that, I think we're done with Pandas. I hope you found this useful and wish you joy in creating your Pandas programs.